Here's a good one. All right, you ready? I'm counting leaves. What's the definition of a leaf? 1 is a leaf. It has no children. 9 is not a leaf, right? So here I have 3 leaves. Here I have 2 leaves. How many leaves does the whole thing have? 5. So what do? I just add them together, right? Easy peasy. All right, what's the base case? Now, remember, in binary trees, I like base cases, right? I like my empty tree. All right, so my empty tree is 0. How many leaves? Well, clearly it has 0 leaves, right? Let's not be weird about this. All right? All right, so does this code work? How many people go, yeah, it looks like good code? How many say it doesn't work? Why doesn't it work? Brilliant answer. Brilliant answer. Reverse psychology, right? All right, so here's the question about this code, is where does the first non-zero value come from, right? Because here, I take answers and I add them. That's not producing the first non-zero, is it? Right? I start with 0, and then I add, I get zeros. I get zeros all the way, right? So this thing is going to return 0. You hear what I'm saying? All right, so anybody know how to fix it? Well, let's try to see if it works. Does the first guy work? You have a big tree here and a big tree here. These are 2 big non-zero numbers. We add them together. That works, right? Does this one work? Yeah, this isn't a leaf. You get 5 leaves down here, then the total number of leaves is 5, right? Does this one work? Yeah, I'll buy that. Does this one work? No, right? This is our first non-zero number. You got to bootstrap it from somewhere, right? All right, so here's my code. If I'm the empty tree, I'm 0. If I'm a leaf, then my answer is 1, right? And how am I a leaf? Well, if my left subtree and my right subtree are empty, right, then I'm a leaf. Yeah. And I'm going to go with the node. A leaf is a node, right? I mean, because look back at this guy here. How many leaves does this have? Well, this is an empty tree, right? So if you're calling it a leaf, then you're counting a leaf down here. And I don't want to do that. I want to say a leaf is a node with no children. It has no nodes, right? It has no nodes. All right, so look at, if nobody's getting the empty tree, let's redo the empty tree, right? So node 2, it does have a left child and it does have a right child, right? The right child is clearly 7. The left child is the empty tree, right? So when we're coming up to this question, right, I'm going to get the base case from the empty tree, the base case from the empty tree, and then I have to form my right answer. And in all other problems before, this code gave me the right answer, right? If this was the number of nodes plus the number of nodes plus 1, I would get the number of nodes, right? But here it gives you the wrong answer. All right, is that making sense? Thanks. Yeah, really, guys, if you're realizing that you're not getting something, holler, because you might be missing something from a while back, right? And there's no problem with that. All right, so everybody get this code then? All right? If I really am a node with a tree with no nodes, then you have no, right? But if you are a leaf, it's 1, and otherwise you sum. Right? Have we done these orders already? Somehow I feel we have. Do we need to do them again? You good? It's kind of, I mean, maybe we didn't think about it recursively so much, right? So I'm given a tree. If the tree's empty, then I'm done. I don't need to print anything. Otherwise, if I'm doing prefix, then I do the root first. I print the 5, right? Here I print the root, and then I recursively do over here, right? And then I recursively do over here. You see the code here? Right? And so prefix, postfix, infix, these various orders, right? This is, infix is a nice one, right? I go to the left, I go to the left, I get 1. I go to, right, I go left, left, left to the empty tree, right? And then I print 1, and then I print 2, and then I print 3, and then I print 4. Oh yeah, here it's written out here, right? Then I print 5, then I print 6. Everybody, yeah? So, oh, actually, in Jackie's slides that he gave me, there's a section, he has more pages on doing this, all right? So if you want more pages on this, he has them.